Hi everybody. To continue our discussion of conic sections, we're going to be covering the circle and the ellipse. What I'm hoping you will learn from this screencast is given an equation of a circle, complete the square if necessary, and then find the center, the radius, and then graph the circle. We'll do the ellipse in another screencast. So what we're focusing on in this section of the textbook, from the conic sections, we did the parabola in the previous 3 screencasts, and then we're going to be doing the circle today and the ellipse, focusing specifically on the circle in this screencast. But the circle and the ellipse are very similar. Here's an example of a circle. And here's an example of an ellipse. So basically, an ellipse is just kind of like a circle squashed top to bottom or left to right. The definition of a circle is the set of all points in a plane that are at a fixed distance from a fixed point, the center in the plane. That fixed distance is called the radius. Now, the standard equation of a circle, if the circle has a center at 0, 0, and the radius is r, is x squared plus y squared is equal to r squared. And the graph of that circle would look like this. The center is at 0, 0. The radius is at r. So one of the points on that circle will be at r, 0. So for example, if we had an equation like x squared plus y squared is equal to 25, well, the center is 0, 0, and the radius is 5. So that means this point would be 5 units from the center because the radius is equal to 5. So the center is 0, 0, and the radius is 5. Now, just like we did with the parabola, let's move that circle away from the origin, and let's make the center of that circle be HK. So now, instead of being at the origin, that point that is the center of the circle can be anywhere in our coordinate plane. And the radius is the distance from the center to the actual circle. So for example, if I have an equation like x plus 2 squared plus y minus 3 squared equals 16, well, the center is HK. H is negative 2 and K is negative 3. So the center is at negative 2, 3. And the radius, since r squared is 16, the radius has to be 4. So the center of our circle is at negative 2, 3. The radius is equal to 4. So if we wanted to find some points on the circle, for example, this point is going to be 4 units up from the center. So the coordinates are negative 2, 7. This point is 4 units to the left. Remember, the radius is 4. And 4 units to the left will be negative 6, 3. 4 units down is negative 2, negative 1. And 4 units to the right is 2, 3. Now let's look at another example. So for the circle x squared plus y squared minus 16x plus 14y plus 32 equals 0, you're asked to find the center in the radius. So what we have to do is put this equation into standard form. We're going to have to complete the square twice, once for the x squared and once for y squared. So we'll put our x terms together and our y terms together, and I subtracted 32 from both sides of the equation. So now what I have to do is add something inside this parenthesis to make a perfect square, and add something inside this parenthesis to make a perfect square, and I'll add both of those to the right-hand side. So half of 16 is 8. 8 squared is 64. Half of 14 is 7, and 7 squared is 49. And that's what I added to both sides of the equation. Cleaning that up a bit, I get x minus 8 squared plus y plus 7 squared is equal to 81. Okay, now what's the center of the circle? The center is 8, -7. And what's the radius? The radius is 9. And here's what the graph of that would look like. So I start at the center, and then I'll go up 9, to the left 9, down 9, and to the right 9. And that's what it looks like. All right, that's it for circles.